Probability using tree diagrams. In this video, you will learn how to use tree diagrams to solve probability problems. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. Tree diagrams are useful for organizing and visualizing the different possible outcomes of a sequence of events. Earlier, you learned about dependent and independent events, and sometimes you don't know whether to multiply or add probabilities. If you are uncertain about whether events are independent or dependent, you should use a tree diagram. A probability tree makes it easier to figure out when to add and when to multiply. Plus, seeing a graph of your problem can help you see the problem more clearly. Example 1. If a die was to be rolled twice, construct a probability tree to calculate the probability of getting 3 twice, getting a 3 and not a 3. First of all, let's calculate the probability of getting a 3 and not getting a 3. The probability of getting a 3 is 1 over 6. The probability of not getting a 3 is 5 over 6. A tree diagram is a drawing with line segments, also known as branches, pointing out all of the different possible paths for the outcomes. At the first row, we can get a 3 or not a 3. We have two possible outcomes, so we have two branches. All outcomes are represented and the outcome is written at the end of the branch. The probability of each branch is written on the branch. We have to extend the tree diagram to second row, and we repeat the procedure. From each possible outcome, we have to draw two branches. The outcome is written at the end of the branch. The probability of each branch is written on the branch. Now it's very easy to find the overall probabilities. The probability of any outcome is obtained by multiplying the probabilities along each branch. The probability of 3 twice is 1 over 36. The probability of 3 and not a 3 is 5 over 36. The probability of not a 3 and 3 is 5 over 36. The probability of not a 3 and not a 3 is 25 over 36. The probability of getting 3 twice is 1 over 36. The probability of an event containing two or more outcomes is obtained by adding the probabilities of each of the outcomes. The probability of getting a 3 and not a 3 is the probability of 3 and not a 3 or not a 3 and 3. The probability is 5 over 18. Example 2. Bag A contains 4 red discs and 1 yellow disc. Bag B contains 2 red discs and 3 yellow discs. A die has 4 faces painted green and 2 faces painted violet. When the die is rolled, if the face is green, then 1 disc is selected from bag A. If the face is violet, then 1 disc is selected from bag B. Determine the probability that the disc is yellow. We calculate the probability of green and the probability of violet from the die. We calculate the probability of red and the probability of yellow from bag A. We calculate the probability of red and the probability of yellow from bag B. Let's start by rolling the die. There are 2 outcomes, green or violet. The probability of rolling a green is 2/3, and the probability of violet is 1/3. If the face is green, we select 1 disc from bag A, and the probability of red is 4/5, and the probability of yellow is 1/5. If the face is violet, we select 1 disc from bag B, and the probability of red is 2/5, and the probability of yellow is 3/5. All possible outcomes are green and red, green and yellow, violet and red, violet and yellow. We multiply the probabilities along each branch. The probability of green and red is 8/15. The probability of green and yellow is 2/15. The probability of violet and green and red is 2/15. The probability of violet and yellow is 3/15. The probability of yellow is the probability of green and yellow or violet and yellow. Therefore, we add these 2 probabilities